So, welcome to massive open online course on chemical process intensification. So, we are discussing under the module the process intensification by monolithic reactor. There are various topics on this. In this lecture under this module, we will discuss something about application of monolithic catalyst, how the different types of monolithic catalyst are actually applied in different chemical engineering processes. So, as we know that the concept of that monolithic structure is converted to the chemical engineering process based on the catalyst are being made a shape to that monolithic structure, and the flow over this monolithic structured catalyst particle, then how chemical engineering process can be that intensified, that we have discussed in our earlier lectures. So, there are different shapes of that monolithic structure, maybe honeycomb structure, even foam structure, even metallic, even sometimes ceramic materials based monolithic structures are there. And then some structures that honeycomb structure, they are that micro channel based monolithic structures are there. And because of that we are getting that certain advantages of that flow characteristics based on which the chemical engineering process can be intensified. So, we have already discussed all those things. Now, let us discuss that several applications based on this monolithic structure catalyst in different chemical engineering processes. So, we know that catalysts are the key for sustainable development in the chemical process industry, and also it is reported that about 80% of chemical products in the world market are actually manufactured via heterogeneous catalytic processes. And for that, an essential tool of the chemical industry is a reactor, and which is procured by the solid catalyst with a certain shape of that catalyst particles like monolithic structure. And the vast majority of such reactors used in the gas liquid processes that contain catalysts in the form of either that stationary or moving particles of various shapes and sizes. And stationary, like that the catalyst particles, if it is supported by that certain metallic or ceramic monolithic structure, then it will be called as stationary. Whereas in some cases you will see not that monolithic structure, but sometimes that solid particles will be moving in a that slurry system, but some other shape like that monolithic structure. But if the reactor is moving with a certain flow rate, then you can say that moving particles, that is monolithic structures, may be moving in a particular processes, and that can be intensified based on that moving phenomena and the hydrodynamic characteristics in that particular moving modes. So, these are the different that majority of such reactors are that you can use that gas liquid reactions, gas liquid solid processes, even some other processes based on that stationary and moving catalytic particles of various shapes and sizes. And that catalysts help to synthesis that product in a resource protective way, like that with less consumption of energy, and in some cases you can say without any formation of byproducts and wastes. And also we can say that this catalyst may integrate various process operations such as chemical reactions, separation and exchange, and momentum transfer, where that integration of the process is being carried out to get the intensification of the particular processes. And in that case, catalyst, especially if they are applied in a structured way, may play important role in the so called integrated approach to environmental protection or remediation of that that unwanted particulate materials in the gaseous stream. And we know that different shapes of the industrial catalyst, like irregular granular shapes, even spherical shapes, ring shapes, monolithic metal, pellets, extruded cylinder, tri-lobe type that catalyst particles, monolithic foam, monolithic that ceramic particles, sometimes it is called millilith that are shown in the figure here in the slides. Even sometimes wagon shaped wheel particles also are being used for particular chemical engineering process, and also meaningless in cross ring, sometimes solid particles of this catalyst particles are being used for particular processes. So, there are different shapes of industrial catalysts that are given here, that you can have a look for that, and also you can have idea how different shapes may act on the that industrial processes by this catalyst presence. Now, if we talk about that application of that monolithic catalyst, that actually you have to go to the earlier stage in 1966, their first application in industry with the clean up of nitric acid tail gases that uses a palladium coated ceramic structure, and in that case that monolithic such catalyst structures were later used in car exhaust as a three-way catalyst for the emission control. So, these are the applications here where we can say that earlier stage they have actually used this monolithic catalyst for the cleanup of nitric acid tail gases. Some other applications here, some examples of monolithic structures, materials and their use are given in the table here, that here automotive application like material, cordierite materials for the catalyst shape, and also cell density, there it is given at different cell densities applied for different hydraulic diameter, and also width of that cell there, and also you can say some commercial application and R&D applications of that automotive application for the monolithic structure. Even other different applications like stationary emissions, mainly oxidation of support for scrubbing of the that particulate materials from the gaseous stream. And other in R&D also they are actually nowadays so many research is going on based on the application of this monolithic shape catalyst in the reactor. In that case different materials are being synthesized, and then how those materials are being made a shape and that will be monolithic at different that shape different structures, then how it can be applied. So, research are going on, particularly we hope that in future there are several other applications will come based on this monolithic structure and also based on the synthesis materials of catalyst and getting the different shape for the process intensification. Now, in India we have that some successful installation of monolithic reactor, where some chemical engineering process are being carried out for phthalic anhydride to successful post reactor installations that utilizes coated cordierite monoliths that exist in India, that is given by Averill et al. In 2000s. And they told that monolithic structure can be used for the intensification of these reactions for production of phthalic anhydride for this cordierite monolithic structure. And in that case the monolithic reactor is integrated into the heat exchanger equipment downstream of the reactor in process unit. And in that case why actually they have used this this monolithic reactor and why they have integrated into the heat exchanger equipment, and they have reported that to increase the life of the main catalyst was the main motivation for this type of unit. So, they are looking for that the increase of life of main catalyst, and in that case they have used this type of monolithic structure, and they also successfully that installed to carry out these chemical reactions for this particular processes. And in the process it is seen that under oxidized byproducts which result from a deactivated main catalyst, and those are converted in the post reactor, and the product is kept within the specifications there. So, Here, so we can say that this is the that how commercially these monolithic catalysts are being used for that particular reactions for the chemical engineering process that we can have. And also there are several other applications, not only these chemical reactions of this phthalic anhydride production, there are other applications, mainly in our that abatement of pollution, that is the main application there. From non-stationary sources, if we talk about that some exhaust gases there, you have to treat those exhaust gases for the removal of carbon monoxide, carbon dioxide, sulfur dioxide, etc. That is coming out from cars or other vehicles. So, it is huge amount every day there are say that ton of that gases are coming out. So, you have to treat those exhaust gases, and in that case that some intensification of the process is required to remove all those gases, that is COX, NOx or SOx gases that is coming out from the cars. So, another important that for non-stationary sources like decomposition of ozone in aircrafts, that also very important. There you have to abate those ozone gases in aircraft that is coming out. So, you have to decompose those ozone gases by catalytically based on that some intensified process. So, that is why these monolithic structures now is giving that best way to convert this ozone into that other derivatives, and also abatement of that ozone from the aircrafts that is coming out. And also stationary sources, in that case selective reduction of NOx is there, and destruction of volatile organic compounds, catalytic combustion, waste incinerators, fluidized bed, coal combustions and diesel engines, etc. So, there are several applications that based on that monolithic structures is for the abatement of the pollution is going on. And in case of catalytic combustion, you will see that particularly it has been of greater interest due to its potential to produce energy there. So, in that case, that catalytic gas phase experiments, monolithic catalysts are found to give olefins with good selectivities from the oxidation of alkanes, that is reported by Govender and Friedrich in 2017. And more recently they have stated that in oxidation catalysis monoliths have that shown promise in the preferential oxidation of carbon monoxide. So, this is the application for this monolithic structure. Now, for slow reactions, if we consider that high catalyst loading, it is of course sometimes desired, and the pure catalyst type of monolith should be used there. So, while for fast reactions or if diffusion is slow, so in that case you have to consider a thin coating with a maximum geometric area there. So, in that case so you have to use that monolithic catalytic reactor based on that criteria of slow or fast reactions. And in case of fast reactions at high temperature, it is limited to single phase such as steam reforming, partial oxidation of hydrocarbons to syngas and oxidative dehydrogenation there. And the first monolithic catalyst used in the treatment of exhaust gases from the cars generated by unleaded gasoline. So, this is also important applications there in monolithic structure catalyst for that particular particulate materials removal from the exhaust gases. And also it is seen that the ceramic monolith structure with aluminum oxide layer as a support to a catalytic active component, and with the mixture of precious metals like platinum, rubidium, palladium, those materials will give you that intensified way of that removal of that exhaust gases from the cars that is generated by gasoline. And the system has that two parts of that that catalytic converter, mainly the metallic monolith pre-heater electrically, that is heated catalytic in converter, and also basic ceramic monolith catalyst as shown in here in the picture. The electrically heated converter is installed adjustment to the entry to basic ceramic catalytic converter here as shown in here figure. This actually figure is taken from that that website is given in the slides. So, that is why the catalytic converter is actually widely used for that removal of gases from the that is coming out from the car by combustion of gasoline there. So, that is why what type of actually that monolithic structure should be used, that metallic monolithic preheater and also ceramic monolithic catalyst also both can be used in that particular catalytic converter. And electrically heated converter is installed adjacent to the entry to basic ceramic catalytic converter, there you have to remember. And monolithic catalytic system of car, here see in the figure it is shown that this converter from the bottom, that there will be simultaneous removal of solid particles and the nitrogen oxide that is from the exhaust gases generated by diesel fuel combustion and generation of the catalytic system there. This is the function of this catalytic converter. And in this case, the first part of the system has a ceramic monolithic catalyst, that is platinum as a catalytically active component is being used, and which actually enables oxidation of carbon monoxide and hydrocarbon into carbon dioxide and also water respectively. So, it is to be actually remembered that there are two parts of this catalytic converter, where in the first part system that ceramic monolithic catalysts are being used to enable the oxidation of carbon monoxide and also hydrocarbon to its carbon dioxide, that is carbon monoxide to carbon dioxide and hydrocarbon to water. And there also you will see simultaneously nitrogen oxides that is present in the flue gases mostly as NOx, that is NO, that is nitrous oxide. They are that oxidized to nitrogen dioxide, while remaining gaseous mixture may pass through other part of the system where solid particles are being accumulated. So, that is why in the first part and second part, that is totally, then the first part, that is carbon monoxide is converted to carbon dioxide and hydrocarbon is converted to water, whereas the second part it will be nitrous oxide to be treated and to give you nitrogen dioxide and also other mixture through this part of the system where solid particles are accumulated. And in case of catalytic fuel combustor in the system with gas turbines, in that case you will see monolith structure are important in prevention of air pollution. In that case, the catalyst reduces activation energy which are actually required for the combustion reactions. And in that case, complete combustion of the fuel air mixture that may occur at significantly lower temperature. But in this case, you have to remember that catalytic combustor are in that they are prevent generation of thermal NOx generally generated at temperature is greater than 1673 Kelvin. And there are other applications of this monolithic catalyst that is in petrochemical industry. In that case, that conversion of alkanes, alkenes and other organic compounds decomposing into that other products by catalyst in presence of catalyst. So, in that case, the conversion of alkanes to more valuable products such as olefins or synthesis gas is very relevant to this petrochemical industry. And in that case, olefins are produced via steam cracking of hydrocarbons, and that is being actually occurred in that monolithic structure. Also, that alkanes are oxidatively dehydrogenated in this monolithic reactor, typically over transition metal oxides to yield olefins and oxygenates in that monolithic reactor. That is reported by Govender et al. 2004. And the partial oxidation reaction over monoliths can also offer shorter contact times. That is why it is advantageous, And also you will see whenever we are actually use or carrying out that partial oxidation reaction in that monolithic structures, it is seen that there will be a higher throughput to produce that syngas with a very shorter contact times. In that case, methane conversion is very important because this gives that that different hydrocarbons via steam reforming, that is the reaction is at lower temperature, that is endothermic reactions is there over a nickel based catalyst. And in this case you have to remember that it is seen that, and also reported by Huff and Smith, that ethane can be converted to ethylene with a 70% selectivity on ceramic foam monolith structures there. And propane oxidation over a metallic monolith coated with platinum aluminum oxide is very important in the case of monolithic structure which are made in metal like that stainless steel and others. And the formation of olefins can be enhanced in the adiabatic reactor with a platinum aluminum oxide coated monoliths there. And in the petrochemical industries there are normal hexane over monoliths. In that case the reaction proceeds by the means of a radial type of mechanism to predominantly form cyclooxygenates with that olefins and also dienes in minor quantities where you can get this oxidation of this normal hexane over these monoliths. So, it is reported by O. Corner and Smith in 2000s there. And the use of monolith type catalyst in a monolithic reactor or formaldehyde production is actually proposed in a patent that is assigned to Haldor Topsoe and that company, that is this is a Denmark company that is reported by Sarup et al. 1992. This company also is using this monolithic type catalyst for the that production of formaldehyde there. So, in this case the adiabatic monolithic reactor reduces the amount of formic acid and also dimethyl ether in product. Now, except this multiphase petrochemical that conversion of different alkanes or alkenes into several products, you can have these monolithic structures applied in multiphase reactions also, like hydrotreating processes. They are hydrodesulfurization, hydronitrogenation, even hydrocracking, sometimes that biochemical processes, alkylation in multiphase monolithic reactor, sometimes organic synthesis like esterifications, those are actually applied in monolithic structures catalyst there. So, in the monolithic reactor they are using this multiphase different type of reactions, and in this case the conventional multiphase reactors are being actually substituted by these monolithic reactors because of some advantages for this that getting the more contact, even the more residence time and also lower pressure drop. There are several hydrodynamic aspects are actually involved in this particular monolithic structures when these multiphase reactions are being carried out. So, conventional reactions like that slurry column, bubble column reactor, trickle bed reactors are there, that is gas liquid reactions. There are some several advantages like back mixing, even that back mixing can be reduced by that structure of that conventional slurry bubble column in a two dimensional column. And also that trickle bed reactors need not be upflow trickle bed reactor, that will be downflow reactors. They are also that channeling of that liquid and gas flow, they are may give that intensification of the process, but still they are that for the reactions that we can further intensify the process by this monolithic structure, where catalyst particles are actively take part for that particular multiphase reactions there. So, in this case whenever you are analyzing these multiphase reactions in this monolithic structure, you have to consider the several hydrodynamic aspects of that. Based on that hydrodynamic aspects, that you can get the intensified way of that output of that multiphase reactions there. you have to study that what is the friction or pressure drop, what is the hold up, what is the liquid distribution over the monolithic structure, even how that residence time distribution actually is there in the inside the reactor. And also there are several geometry of that liquid distribution should be considered whenever you are doing or the multiphase reactions are being carried out in the monolithic reactor there. So, often the catalyst is a solid phase, you will see that or a living organism immobilized in the solid monolithic structure. In that case, that reaction components can be gaseous or liquid state. So, there are several combination of the reactions in the multiphase systems like gas solid reactions, liquid solid reactions, gas liquid solid reactions, gas liquid liquid solid, even gas liquid liquid solid also there. So, in that case there are several that multiphase operations should be considered, and for the particular chemical engineering process like gas solid, there are several applications of gas solid reactions, maybe sometimes drying process is gas and solid. Even that sometimes that catalytic cracking in the gaseous medium, coal combustions to get the several hydrocarbons, even that to produce the power there. Liquid solids, they are leaching operations, you have to extract some that liquid from the solid materials, like that you have to extracting oil from the seeds like this. Gas, liquid and solids, they are catalytic reactions in a slurry reactor, in monolithic reactor, gas liquid reactions. Even liquid liquid solids, sometimes in presence of that solid particles, catalytic extraction is there. So, liquid liquid extraction in presence of solid particles there. Even gas liquid liquid solids, sometimes that liquid liquid extraction in gas induced operations, where that you can get the mixing phenomena, even intense mixing may that result the the more yield of the extraction processes there. And there are several other that operations that in presence of monolithic structures based on this combination of that gas liquid solid reactions there. So, you have to supply those gas and liquid through that monolithic reactor. In that case, it may be co-current, it may be counter current operations. So, with respect to the relatively small channel diameter, you can use this the monolithic structure, and for counter current operations maybe in monolithic structure will be very limited, because it is very difficult to get that counter current operations and gas and liquid in the monolithic structure, because this channel size is very low. So, it is actually very convenient to get that co-current operations of gas and liquid, whereas that in most cases solid phases is in movable, but there are designs with the moving bed applications also there. That moving packed bed or moving monolithic reactor is there, movable monolithic reactors for that centrifugal action, by which you can separate that some liquid particles from the solid, or extraction or adsorption processes also by this that centrifugal action of this monolithic structure. So, in that case you can think about that how moving bed can be applied for that particular chemical engineering processes based on that monolithic structure. Now, you have to remember some basic things for this gas liquid solid catalytic reactions there. So, in that case what should be the hydrodynamics, like regimes, if it is gas liquid reactions, then what will be the size of the gas slug, what will be the size of the liquid slug is there. So, you have to control of those things to get that intensified way of process output. And also safety and environmental aspects is very important that you have to consider for that catalytic reactions, whether it is giving that hazardous materials as an output or not. So, you have to select the solvent in such a way that you can minimize that that hazardous materials to be coming out as an output byproduct. And also you have to use that that catalyst which will be selective, that may be qualified with that diffusion length, loading, and also profiles there. And also that how to handle that catalyst in the monolithic structure, that you have to consider how to distribute the liquid through that catalyst particles in the monolithic structures. And also if it is to be regenerated, then how to remove from that catalyst particles from that monolithic structure, that is also important there. And whenever you are supplying any heat for that particular chemical engineering reactions there, and also how to remove those heat there, if there are that heat continuous there, maybe that sometimes thermal properties of the materials may be degraded. So, in that case you have to wisely use that that supplying of the heat, and also its removal by that sometimes heat exchanger or other mechanical devices to control that heat. And also you have to think about that transport resistances, maybe rate and selectivity there. If is there gas liquid transfer or gas solid reactions is there, how that that liquid thin film will be acting or play a role in that gas liquid reactions, and also in the solid surface how porosity will be taking part for that particular reactions to get its that selective yield there. Now, in this case you have to remember these things, that topology of this that qualitative rating of the technical benefits of this monolithic catalyst in different processes. Like if you are considering that hydrodynamic aspects, then type of reactions will be that low pressure drop based reactions, low fouling potential based reactions, even catalyst bed uniformity, and also high counter current hydraulic capacity should be considered in that case for the particular reactions. In this case you can carry out that gas solid reactions or liquid solid reactions, that may be fast or slow. In this case fast and slow both you can have, but sometimes that for high counter current hydraulic capacity based reactors you cannot consider that gas solid or liquid solid reactions at this hydrodynamic conditions. And for gas liquid solid, there you can apply this low pressure, low fouling, catalyst bed uniformity, and also high counter current hydraulic capacity based reactions in considering that hydrodynamic aspects for fast and slow reactions. And also reactive performance, if you consider that, you will see that better solid irrigation or utilization should be considered, higher catalyst load or pressure drop ratio to be maintained, even high mass transfer or pressure drop ratio to be considered, and good dynamic response to be that taken care, and also that better temperature control to be there for that particular reactions. In that case that how fast and slow reactions are happened, even that maximum cases in the fast reactions high mass transfer or pressure drop ratio, in that case you can get the fast reactions for the gas solid reactions, and also slow reactions also can have, but to be limited. But in case of structural that in this case enables gas shell thin thickness of catalyst systems, and good structural integrity, low catalyst attrition. In that case you can have both fast and slow reactions, but slow reactions will be limited, whereas in gas liquid solid, in that case also you can have that fast and slow reactions, whereas slow reactions will be limited. So, here in this case that plus indicated in this figure A, B, C, here plus is small benefit, double plus is solid benefit, and triple plus is very significant benefit, and catalyst supported on an inert monolithic backbone that will also be considered in the case of that catalytic structure of monolithic reactor. And also bulk monolithic catalyst to be considered if is there that that there will be a good structural integrity, or they are not, that should be considered for that fast or slow reactions of gas solid or liquid solid reactions. Now, main question is that why this monolithic reactor is advantageous, that is compared to the conventional slurry and trickle bed reactors. In this case, you will see for monolithic reactor, the catalyst can be coated as a thin layer on the channel wall, that is advantageous, whereas it is not in that conventional slurry or trickle bed reactor. And also in the monolithic structure, you will see larger channel geometries, that is internally finned monolith channel allow counter current operation of the gas and liquid there. And in the catalyst inventory can be increased by using thicker coating or using a monolith extruded from the catalyst support, and also other that structure based on that catalytic type. So, in that case one example that an alumina silica that monolithic structure can be used for this catalyst inventory to increase by its thicker coating or using a monolithic extruded from the catalyst support. And the high cell density of the monoliths creates a high geometric surface area, that is one advantages, where main advantages that you may not get that enough back mixing here, maximum that slug flow phenomena or plug flow phenomena will give you that that better performance of the reactions and yield. And also scale up is the issue there. Scale up is in principle straightforward in monolithic reactor. Monolithic reactors are intrinsically safer, and also when the feed of liquid or gas is stopped, the channels are quickly emptied, and also the monolithic channels have no radial communication in the terms of mass transport, and the development of runaway by local hot spots in a trickle bed reactor that cannot occur here. So, in the trickle bed reactor we are having that local hot spots, but where in this monolithic structure we are not having that local hot spots there. And also a moving bed adsorption process is one of the important application in monolithic structure moving bed reactor. In that case deactivating catalyst, reforming, demetallization, and also dehydrogenation, even that other regeneration processes of catalyst that can be done in the monolithic structure. Whereas the solid trickle flow reactions they are in the trickle bed reactors are generative process there. In that case you can use that movable reactors instead of this monolithic reactors, but sometimes that hydrodynamic aspects may give the disadvantage of this that trickle bed reactor in this movable condition compared to that monolithic structure, because they are that the transfer of that gaseous components to the solid components, it actually depends on that energy transport there. Whereas in that trickle bed reactors it may require more energy dissipation compared to that monolithic structures, because they are that channeling of that radial distribution of that gas liquid will give you that higher energy distribution required for that trickle bed reactor. Whereas hydrogenation of alkyl anthraquinone in the production of hydrogen peroxide are generally used in commercially actually installed monolithic catalytic reactor. In that case hydrogenation of methyl styrene to cumene, another example we have to remember, and also that some biocatalyzed reactions are being used in this that monolithic catalyst in multiphase processes. So, this hydrogenation of dinitrotoluenes to toluene diamine, and hydrogenation of benzaldehyde to benzyl alcohol. So, this type of that applications are being commercially available here for this multiphase reactions in monolithic reactor. Now, another important applications, it is called Fischer-Tropsch synthesis. So, monolithic catalyst for Fischer-Tropsch synthesis consists of long parallel channels where this 0.5 to 3 millimeter internal diameter are being used to separate different thin walls of this monolithic structure of 0.1 to 0.3 millimeter, and then the active metals which are included with or applied to the support may include metals or combination of metals such as cobalt, iron, copper, nickel, platinum, rubidium, even rhenium, and also ruthenium. These type of metals are being used for the catalytic support. And monolithic reactors usually work in a temperature ranges from 188 to 194 degrees centigrade up to 240 degree centigrade. And in that case, synthesis gas composition are from stoichiometrically excess carbon monoxide to the excess hydrogen to be maintained. Now, some comparison of the monolithic reactor with multiphase reactors here based on that energy input, catalyst efficiency, pressure drop, catalyst separation, catalyst loading, catalyst replacement and also experience. If we consider that energy input, in that case monolithic reactors are required low energy, whereas slurry reactor require medium energy for the stirring generally, and for trickle bed reactor it is high energy is required because there are frictional pressure drop is high. And also in terms of catalyst efficiency, if we think about that monolithic reactor will be high that is thin active layer will be there, that is why catalyst efficiency will be high there. Also slurry reactor also it is high if you are considering the small catalyst particles, and in case of trickle bed reactors it will be low because in the trickle bed reactor you cannot use the small particles, it is made only large particles due to the pressure drop there. And also if we consider that pressure drop, of course that monolithic reactors it will be insignificant, whereas in the slurry and trickle bed reactors may be medium and high respectively. And for the catalyst separation, this monolithic reactor is not required that criteria, and for the slurry reactors it is of course required because to regenerate that catalyst particles you have to separate those catalyst particles from the multiphase mixture. Whereas in the trickle bed reactor this catalyst separation is easy since the the size is very high, so you can easily separate. But for the slurry reactors it is sometimes not easier because you have to invest some price for filtering those small particles there for the regeneration of that catalyst particles. In case of monolith reactor, you will see medium or small scale of catalyst loading is required, whereas slurry reactors it is medium or small scale of catalyst loading is required, whereas in case of trickle bed reactor it is high. And in case of catalyst replacement, monolithic reactor is very difficult, whereas slurry reactor is very easy because continuous exchange during the operations can be done. And also in the trickle bed reactors also this replacement of the catalyst is very difficult. And monolithic reactors, the two phase extensive multiphase reactions are there, whereas other different types of that gas liquid solid, even gas liquid liquid solid reactions sometimes limited, whereas in the slurry reactors it is high because that you can easily handle those that slurry mixture in the slurry reactors, whereas in the trickle bed also it is very high. So as per that comparison of this monolithic reactor with multiphase reactors, we can conclude that in maximum cases that monolithic reactors are giving that better performance compared to the slurry and trickle bed reactor, but some aspects it may not be there. So case to case you have to use that reactors in particular which cases that energy required will be that more that you have to sometimes avoid for those reactors for the particular reactors. But sometimes for pilot scale operations sometimes the slurry reactors will be better way to do that multiphase reactions. Like Fischer-Tropsch synthesis, it is better that in slurry reactors, whereas in monolithic reactor it will be sometimes that less yield will be giving by this monolithic reactor. Other multiphase processes in monolithic reactors, apart from that gas liquid solid type, also liquid liquid solid and gas liquid liquid solid type catalytic reactions are possible using this monoliths. Of course, there are the hydrodynamic aspects to be considered during that performance analysis of this monolithic reactor. They can be applied in stripping, extraction, evaporation, drying and distillation also. And also in this case you will see that straight channels based monolith are ideal for fixed or moving bed applications, and structured trickle bed reactors are important where the longer residence time can be achieved than in a straight channel monolith is there. And another important applications in power sector. More recently you can say that there has been renewed interest in the use of monoliths for reactions where energy efficiency and cost reductions are required. So, in particular this include catalytic combustion for power generation, the selective oxidation of alkanes and preferential oxidations is there. Here see this video how this power is generated based on this monolithic reactor. How in this case you will see by power you have to heat this methane gases to convert it into that carbon and hydrogen. So, you will see that here there is how this cracking of this methane gas is happened in this monolithic reactors, and you will see that this monolithic how this methane being cracked into carbon and hydrogen, and then this hydrogen gas is passing through that other steam generator unit. By this that by hot air with this hydrogen gases there will be that circulation of this hot gases through the turbine of this hydrogen, because this hydrogen gas will be giving that less pollution to the environment without that carbon monoxide or that other exhaust gases. In this case this hydrogen gas will with this hydrogen gas that heated up by this hot air, and then that steam will be generated and then steam will that create that turbine and the power will be generated here. So, this is the basic process by which that power can be generated by this monolithic reactor by that catalytic cracking of this methane into hydrogen gas. So, the selective of oxidation of alkanes and preferential oxidation of carbon monoxide is that happened in this case. So, in the catalytic combustion approach, methane or natural gas can be converted over a noble metal based catalyst to drive a gas turbine for power generation. So, we have discussed the different aspects of application of this monolithic reactor based on that multiphase reactions and other applications. Also in the catalytic combustion approach, the methane or natural gas can be converted over a noble metal based catalyst to drive that gas turbine for power generation. In this case, the researchers focus on converting that fuel or syngas mixtures by a combination of heterogeneous homogeneous reactions over platinum based catalyst coated onto micro channels. Even other metals supported on coated cordierite. Cordierite is more active and thermally stable in the catalytic combustion of methane than the catalyst in powder form there. So, based on which this monolithic reactor is actually giving more that environment friendly process of converting this methane to hydrogen, which will convert to the power. So, this is the application in the power sector how these monolithic reactors are being used. So, I think we have discussed several applications of this that monolithic reactors for single phase reactions, multiphase reactions in petrochemical industry, how these monolithic reactors are being used for different chemical reactions, even multiphase reactions, how it is actually compared with that slurry reactors, packed bed reactors or trickle bed reactors. Then monolithic reactors, how actually for that gas liquid reactions, gas liquid solid reactions are being carried out in this particular microchannel based monolithic reactors, and how it will be giving the better performance that we have discussed. Even based on the hydrodynamic aspects, how these monolithic reactors can be actually analyzed for the better performance, that also we have discussed some extent. In the next lecture, we will discuss some hydrodynamic aspects of that monolithic structures, how that monolithic structures can be assessed by that hydrodynamic aspects. So, I would suggest you to go further for better understanding of those, that different applications of monolithic reactors for different chemical engineering processes. Here some references are given. So, thank you.